Hello guys, in this video I am explaining one of the important concepts of operating system, that is process and its states. Before understanding what is a process is, we need to understand program first. So let me start with the program. So, so what is a program? A program is a piece of code, right? This code may be single line or millions of lines, it depends. But a program is a piece of code that can do some task. I can write this program in any one of the programming language like C, Java, etc. Right? A program is a piece of code that can do some tasks. Here I am taking an example of a program that is written in C programming language. Program to add two numbers. Here you can see here, this is a simple program to add two numbers. Here I am declaring three variables a, b and sum, where I am going to read two values here, a and b. I am going to add those values. After adding those values, the result will be stored in the another variable called sum. Right? After the successful execution of this program, the value 0 is returned to the OS. If a 0 value is returned to the OS, that means program is executed successfully. If a non-zero value is returned to the OS, then that means a program is not executed successfully. But here in this case, I am returning 0, that means my program is executed successfully. Right? So program, this is a simple program, right? So now, what is a process? What is the difference between a process and a program? Right? A process is also basically a program only, but when a program starts executing, a program becomes a process. Understood, guys? A program is a process is also a program. A process is also a program. When a program starts executing, it becomes a process. Understood? And one more important thing, the instructions in the process is going to be executed in sequential order. That means one by one the instructions is going to be executed. Understood, guys? Right? Process is also a program, but when it is under execution, a program can be called as a process. Now, next. So when a program becomes a process, you know that I already told you, right? So in simple terms, when our computer programs is in a text file, it is a program, right? Definitely. When we start executing it, a program becomes a process. And one more important thing, when a process is created, we have to allocate the memory for that process, right? Here, when you create the process, the memory, right, the memory can be divided into four sections here. The first section is stack, second is a heap, third is a text, and the last one is a data. Right, guys? So let me see with the diagram. See here, this is the memory layout of the process. When you create the process, the memory will be allocated in these four sections. Let me discuss each sections in detail now. So see here, what is a stack? The process stack, obviously the stack contains a temporary data. What is a temporary data here? Temporary data such as methods, function parameters, return address and local variables. So for example, in our program, that is, see here, so in our program that is adding the two numbers, here what are our temporary data? Here we are using a local variables like you can see here, int a comma b, sum, right? These local variables are stored in the stack. Not only the local variables, the return value, that is return 0, is also stored in the stack, right? So next is what? Heap. This is a dynamically allocated memory to a process, right? During the runtime, this memory is allocated, right? Initially I am not going to use this heap. Based on the requirement of the process, right, I'm going to use this in the runtime. For example, if a process needs an extra memory, I can use this heap to allocate that. Understood, guys? Next, the text. This includes, obviously, this text section includes the details of the program counter. So what is a program counter then? The program counter always have the details of the current activity. For example, in our program, the details, what details a program counter can save. For example, the program counter can save that in our program we have 8 instructions. So PC value will be 8. Suppose in our program, if the instruction sum is equal to a plus b is executing, then the program counter value of the current activity will be 6. Suppose if a header file is stdio.h is executing, then the program counter value will be 1. So understood, guys? The program counter always what's the value of the next instructions to be executed. So these details, the text, the instructions details will be stored in the text section. So the last section contains that is data section, the global and static variables. But in our program, that is example program adding two numbers, we are not using any global variables, right? So that's why I'm not taking those section details here. If the global variables is used, then that will be stored in the data section. Next, what is a process state? So see here, when a process executes, it passes through different states. Obviously, maybe for example, it may be in a starting state, from starting to ending state it can move. So based from different state it can pass through, right? So generally each process contains 5 states. We will discuss the states now, right? Understood, guys? So now see here, these are the different process states. In any operating system, if you take any operating system, these are the right same states, right? Same states you are going to study here. So first is a start state, second is a ready state, third is a running state, fourth is a terminator state, and the next last one is a wait state. So here a process can move from one state to another state. So we will discuss each states in detail, when it will be in start state or when it will be in wait state. Those things we will discuss now. A process will be in a start state, right? When it will be in a start state, this is the initial state when a process is first started or created. When you first create the process, it will be in the start state. So when it will be in ready state, the process is waiting to be assigned to a processor. For example, when you create the process, right, before allocating the processor to the process, it will be in ready state. Ready processes are waiting to have the processor allocated. Yes, right? The process needs the processor to be used, right? Obviously, if you are not allocating the processor to the process, it will be in the ready state, right? Once you allocate the processor to the process, they can run, right? Understood, guys? And process may come into this state after start state also. For example, it can come from start state to ready state, or it can come from running to ready also. You can ask a question, when it will come from running to ready state? Suppose if a process is running, when you interrupt is occurred, when you right when you are going to give the control to the other new process, then it can move from running state to uh, ready state, because you are giving the control to the other process. Understood, guys? So when it will be in a ready state, when a process is not allocated the processor, it will be in ready state. Once you allocate the processor to the process, it will move to the running state. Understood, guys? Now what is in running states? I told you, right? Once the process has been assigned to a processor by the OS, right, the process state is set to running, and processor executes the instructions. Running means what? The process instructions will be executed. Now what is the waiting state here? Process moves into the waiting state if it needs to wait for a resource. For example, I already told you, right? When you have a shortage of resource, you may stop that process from executing, right? It will be in waiting state until you allocate the resources to that. For example, see here, waiting for the user input, waiting for file to become available. It may wait for, right, some resources. Then the process will be in the waiting state, right? So see here, guys. So terminated state. So what is a terminated state? Once the process finishes its execution or it is terminated by the operating system, it will move into the terminating state. So once everything is completed, your process can move to terminated or exit state. Understood, guys? So let me brief once again. So your process will be in a start state when you create the process. So it will be ready state where it will be the process is waiting to be assigned to a processor. Ready processors are waiting to have the processor allocated to them, right? So they can run. So it will be they are ready. There will be in a ready state. Next, running. Once the processor is allocated, the instructions are executed. So it will be in running state. So process moves into waiting state if it needs to wait for the resource, that is waiting state. Lastly, everything is executed, every instructions is executed, it will move to exit state or a terminated state. So these are the process states. Now, what is a process control block? PCB. It is one of the important concept in operating system. What is PCB? A process control block is a data structure maintained by the operating system for every process. When every process is created, each process is going to get a process control block. Operating system is going to maintain the process control block. Don't get confused with the memory layout of a process and the process control block. Memory layout is different. Memory is allocated when a process is created. See, in the same way, when a process is created, along with the memory, process information needs to be maintained by the OS also. For that purpose, we need a PCB, process control block. Now, let me see what is a process control block, what are the section it contains. So see here, these are the components of process control block, that is process ID, state, pointer, priority, program counter, CPU registers, IO information, accounting information, etc. So these are all the components that a PCB is going to take care of. So let me discuss each components in detail. So PCB is like a data structure, guys. This information is going to be maintained, right? So see here. So what is a process state? This is the first section in the PCB here. The current state of the process. That means I told you, right, a process can move from one state to another state, that is running state, ready state, start state. So a process can be in any one of that state, right? Those details will be recorded in this process state. For example, you can see the current state of the process, that whether it is ready, running, waiting, or whatever, right? So these details will be recorded or saved in this process state. Next is process privileges. I told you privileges means it is like permissions. You are going to give the permissions who is going to execute that process. This is required to allow, disallow access. You are not going to give the access to everybody, right? If you don't want to, if you don't want that process is executed by everyone, you can give a selected people, right? You can give that selected people a special privileges. Those privileges, those permissions details will be stored here. This is required to allow, disallow the access to the system resources. Next, what is a process ID? For every employee, the institution is going to give a ID, right? In the same way, for every process, to identify the individual process, each process should be assigned a ID, that is unique identification for each process. Each process identification number is different. Understood, guys? So next is a pointer. So when a process is created, when a parent process creates another process, that newly created process become a child process. So that's why always a child process contains a pointer to the parent process. So these pointer details should be there because I need to find out whether it's a parent process or a child process. Next is a program counter. So program counter is a pointer to the address of the next instruction. I already told you, right? So program counter is going to store the address of the next instruction that is going to be executed for this process. I told you, right? Sum is equal to a plus b, those instructions. So like that. So your instruction can be, right? Your instruction can change, right? That's why the value of the program counter can also change. Next, CPU registers. Various CPU registers where process needs to be stored for execution for running state. For example, suppose while running, you need to store some intermediate data. For example, sum is equal to a plus b. When you are adding the two numbers, you want to store the value of a in the intermediate register. Then once the value of b, if you find out the value of b, then you can take that intermediate value of a and you are going to add that with value of b, right? So intermediate values can be stored. For that purpose, CPU can use the registers. This process can use the registers to store that intermediate values. Next is what? CPU scheduling. So process priority and other scheduling information. For example, CPU scheduling means we need to schedule the resources for a particular process. On what basis you are going to schedule a particular process resource means based on the priority, right? Highest priority process gets the resources first, lowest priority process gets the resources in the last. So that's why, so those details, priority details will be there in the CPU scheduling component. So next is a memory management information. So this includes the information of page table, memory limits, segment table depending upon memory used by the operating system. So right, so this memory management information means it includes the information of tables, paging table. We are going to learn about paging, demand paging, those things in the coming videos. So far you should know that. So this memory management information field contains the details of the information of the pages, memory limits. For example, how much memory we have to use for a particular process, that memory limits, all those details will be there in the memory management information. So next is accounting information. So this accounting information includes the amount of CPU used for process execution. That's fine. For example, one process can take more CPU time and another process can take less CPU time. So those things, how much CPU time a particular process is going to take, how much CPU time is going to take, those things are recorded in this account information, right? So not now lastly, what is IO status information? This includes a list of IO devices allocated to the process. If you want to execute a process, you need some input output instructions, right? So you can give the input from the keyboard or you can give input from the mouse. So those details, so which are the list of IO devices that are assigned to the particular process, right? Those details will be there in the IO status information, right? So next, one more important thing you have to remember is the PCB is maintained for a process throughout its lifetime. That means, alright, so if you are not going to delete the process, that information related to the PCB, it will last for the lifetime. Once you delete the process, these details will be deleted, right? So these details, the PCB details, are throughout its lifetime, right? If you won't delete this, it will be there for a lifetime. Once you delete the process, all these details of the PCB will be deleted, right? So that's it guys, hope you understand the concepts. Thank you.